Hello learners, how are you all? This is your KP Sir, Krishna Prakash. So today we are going to discuss about TNPSC, Tamil Nadu Public Service Commission AE Exam 2024. This Sunday, last Sunday, exam is conducted. So this last Sunday AE exam, 200 questions. Out of 200 questions, around 23 questions are from environmental engineering. Today we are going to do solutions of that TNPSC AE environmental engineering questions solutions. So this TNPSC AE environmental engineering questions, it may help you for all state any AE environmental questions, for all state AE, JE, AEE state exam questions, and also this will help you for SSC JE prelims and mains questions. The level of questions is exactly equal. So if you are preparing for a state exam, if you are preparing for SSC JE, if you are planning for state AE, AEE or polytechnic lecturers, I would like to suggest you to solve all different states AE, JE questions, so that you have a lot of knowledge regarding the subject and covers wider area of the subject, so that it will help you to crack your own exams. And learning new questions, improving your knowledge and knowing about in-depth concepts which are not known previously. So in this regard, I am going to do the videos on different state AE exams, SSC JE exam, prelims, mains, different state AE, AEE exams, previous year question solution. I start with this because this is recently completed last Sunday, 2024 Tamil Nadu Public Service Commission AE exam. So I am here first to announce we have launched a new batch. So most of the students might know or might not know. Myself, Rajendra Prasad Sir and Amit Vijay, we are dealing with the all subjects of technical as well as general studies related to SSC JE. Myself and RP Sir will finish all civil engineering technical subject syllabus. Amit Vijay Sir is going to deal with all general studies. The entire syllabus for SSC JE prelims mains, all state AE, AEE, SSC JE, all state AE, AEE, JE questions, syllabus, its questions, PYQs and some practice question in a single course. So you understand the most experienced teachers are teaching on this for SSC JE and state AE platform, exclusively by your beloved KP Sir and RP Sir. So in this regard, we launched already one new batch recently. I have started with open channel flow. So guys, do join our courses, exclusive KP Sir and RP Sir courses. You can understand the subject in-depth concept, where we are covering required theory and formula notes, we are covering PYQs and its solution, so many practice questions, and that unlimited number of question solution will give you confidence in cracking the exams. So do guys, do join our courses, use our universal code KP Civil and start your learning. So now coming for the first question. Thickness of ozone layer is measured. Thickness of ozone layer is measured in British thermal unit, Clark's unit, Dobson unit, parts per million. Parts per million or ppm, parts per million or ppm, mg per liter, that we use in water pollution regularly and air pollution regularly. But they are not asking for ozone. Please understand. Question is not about ozone and it is not about concentration. If it is about concentration, Clark's unit is concentration unit, milligram per liter, parts per million, these two are related to concentration only. But they are asking about thickness of ozone layer. Thickness of ozone layer is Dobson unit. Thickness of ozone layer is given by Dobson unit. One Dobson unit, it is represented by du. du. 1 du, 1 Dobson unit is equal to 2.69 million ozone molecules. 2.69 into 10 power 6 ozone molecules, O3 molecules. What is this 1 Dobson unit? 1 Dobson unit represents 2.69 million ozone molecules. This many required to form 0.01 mm thick ozone layer. Thick ozone layer means to make ozone layer of 0.01 mm thickness. To make ozone layer of 0.01 mm thickness, 1 Dobson unit is required. And that 1 Dobson unit and in this 0.01 mm thick layer, how many ozone molecules? 2.69 million ozone molecules are there. Got it? 0.01 millimeter thick layer of ozone to be formed by taking 2.69 million ozone molecules, and it is formed. It is forming at 0 degrees Celsius temperature, 1 atmospheric pressure. That is going to form at 0 degrees Celsius temperature, 1 atmospheric pressure. And this many ozone molecules in how much area? 1 meter square area. 2.69 molecules of ozone in 1 meter square area form a thick layer of 0.01. So, for example, we consider, so this is 1 meter square area, okay? This is 1 meter square area. In this 0.01 mm thickness, that is equal to 2.69 into 10 power 6 ozone molecules. Ozone molecules. Now, what is global standard average of ozone layer thickness? Global standard average. Worldwide ground level average of ozone thickness 300 Dobson units. 300 Dobson units. What is meant by 300 Dobson unit? 300 into 0.01 mm. What is global average thickness? 3 mm. Global average thickness is 3 mm. Global standard, worldwide standard average thickness of ozone layer is 300 Dobson units. 300 into 0.01 mm, 3 mm, 3 mm. You consider ozone hole average. So, at some location ozone hole is forming. At some location ozone hole is forming. Thickness is reducing. Thickness is reducing. That ozone hole average is 100 Dobson units. 100 Dobson unit. 100 into 0.01 1 mm thickness. So, in a normal region, it is 3 mm. In a region where ozone hole is forming, it is 1 mm thickness. This is mostly this much depth nobody can ask, but by chance in SSC JE main, GATE environmental science and engineering paper, there is a possibility to ask this much. And also sometimes engineering services exam general studies paper. ESC general studies, GATE environmental science and engineering, SSC JE mains, and some states have AE environmental. Rajasthan RPSC AE JE environmental posts are there. Even sometimes BPSC AE environmental posts are there. For that it may helpful. Moving on to next question. So, most significant harmful primary gaseous pollutant. First important is most significant harmful primary gaseous pollutant in vehicular emission. The two important primary pollutants from vehicular emission, carbon monoxide, nitrogen oxides. So here there are no nitrogen oxides. Answer is carbon monoxide. Because they are asking vehicular air pollution. From vehicular air pollution, carbon monoxide, oxides of nitrogen, ozone also will be released. But ozone is a secondary, it's not primary. Question very clear. We are in hurry, we feel that ozone is getting released, secondary pollution, but not primary. Primary is carbon monoxide. Among the following, the only secondary pollutant is, just now we said na, only secondary pollutant, just now we discussed only secondary pollutant, nothing but ozone. Secondary air pollutant, na, ozone is a secondary air pollutant. Now, which of the following valve provided to control flow of water in distribution system? Controlling the flow of water in distribution system, we are having so many valves. Check valve, sluice valve, scour valve, air valve, so many valves. But very important, at street corners where pipelines intersect. At street corners, interaction of pipes. At a street corner, pipes are coming like this, na? Pipes are intersecting at street corners. In this junction, what kind of valves are required? What kind of valves are required? Sluice valve, which is called gate valve. Na? Sluice valve, gate valve is required. At junctions to stop the flow, to control the flow, to stop the flow at junction where pipes are intersecting, at street corners, we need sluice valve. Most reliable system means dependable system. Reliable system of distribution is system. So in the distribution of water, most reliable, combined pumping and storage, gravity, pumping without storage. So if you take pumping system, in pumping you need electricity. In pumping you need centrifugal pumps, motors. There may be power cut. There may be non-working condition of pump and motor. There may be device non-functioning. But when you go for gravity, higher head to lower head water will flow. No need of pump, generator, motor, electricity. Just you need to put the pipe from higher head to lower head. It is most reliable. Not at all depending on other accessories. Still just you need to give the pipe from higher head to lower head. Water will flow. No need to depend on X, Y, Z factors. Directly water will go. The fluctuating demand is met with to be met with a constant rate of supply from treatment plant by providing an adequate storage in distribution reservoir. So when we are talking about a distribution system, if you are going to provide adequate storage, you are talking regarding adequate storage. In a distribution system, you are talking regarding adequate storage. Very important here, fluctuating demand. You know, storage capacity of reservoir, that is equal to balancing storage breakdown storage plus fire storage. So that balancing storage and breakdown storage, na? These two we are taking some percentage of total discharge depending upon city condition to city condition, depending upon population data. Breakdown storage mostly 25% of total discharge. Fire demand, we have some empirical equations, we have some calculation related to data, Indian Fire Department formula we can take. But this one, na, balancing storage depend on fluctuations of supply and demand. Uniform supply and variable demand. Every day we are supplying water constantly. Every hour consumption is varying. Amount of water supplied by the pipe hourly constant. Amount of water sent from reservoir to the city hourly constant. But water consumed by the city population, it's not constant, it is varying, fluctuating. So that fluctuating is balancing storage. Cumulative storage, emergency storage, equalization storage, useful storage. Do we have any balancing storage here? Do we have any balancing storage here? This balancing storage is there, na? It is also called equalization storage or operational storage. Balancing storage is also called equalization storage or operational storage. So answer, you remember like this, na? Balance is equal to equalization. You are going to equalize the fluctuating demands in the city. So balance is equal to equalization. Option C. A fireman intends to reach window. A fireman intends to reach window 25.5 meter above ground level with a fire stream nozzle having cylindrical tip of 30 mm in diameter. Cylindrical tip of 30 mm in diameter. Discharge of 1140 liter per minute. Velocity you can consider. Discharge by area, just you calculate 1.14 meter cube per minute. So convert it into second. Minute to second conversion divided by 60 we have done. Minute to second conversion divided by 60 we have done. Area pi by 4 d square. Diameter 0.3 mm. Sorry, 30 mm. 0.03 meter. So what are you getting the answer? Please write down there. You just calculate. Just velocity is equal to discharge by area. Discharge is 1.14 meter cube per minute. 60 minute to second. Pi by 4 d square. You can get the answer. So you can get 26.88 meter per second. You are going to get 26.88 meter per second. Eutrophication of water bodies. Eutrophication of water bodies. Discharge of toxic substances. Discharge of excessive nitrogen and phosphorus. Discharge of excessive BOD. Discharge of excessive suspended solids. Eutrophic lake. Excessive deposition of nutrients due to high rate of photosynthesis. Photosynthesis going to happen more amount of nutrients. That nutrients contain accumulation after accumulation and degradation. Excessive discharge of nitrogen and phosphorus. The nutrients released into water nutrients consumed by bacteria, nutrients degraded by water and microorganism. So finally, lake is excessively flooded with nitrogen and phosphorus. Option B. Sewers are allowed to flow full. Sewers are not allowed. Yes, always in the sewer what we need? Sewers are always designed for. This is a sewer pipe. This is a sewer pipe. Always sewer pipe is designed for partial flow, exactly half flow. We never design the sewers for full flow, na? We don't want a full flow for sewer. That is true. It's true. True. Reserve space in the sewer takes care of fluctuations. Yes. Fluctuations in the sewage flow to be taken care. That is the reason why we are putting sewer half flow. To accommodate flow fluctuations. Primary, first and foremost reason. We have other reasons also. To accommodate flow fluctuation is primary reason. To allow gases to flow over it. Secondary reason. To make proper no silting, no scouring condition. To achieve no silting and no scouring condition also we can make it. But basic primary instinct here to take care of fluctuation. So what is the answer? Both assertion and reason are true. R is correct explanation of A. Both assertion and reason are true. R is correct explanation of A. The pump which permits sewage solids to pass out with liquid sewage. Very important. Without clogging the pump. So there is no word water pump. In sewage we never use the water pump. Water pump is different. Sewage pump we are not talking about it. So when you are pumping the sewage using some pipe and pump and motor, the pump is pushing sewage water, and while it is pushing sewage water through the pump, the sewage solids does not settle and does not clog either in the pipe or in the pump. That such kind of pump. What is such kind of pump we are talking over here? So when you come for the reciprocating pump in a very, very olden days they use it for reciprocating pump. But the problem with the reciprocating pump is its initial cost is very high. So for very huge discharges, that too for sludgy solids, to accompany sludgy solids, for very huge discharges, to accompany sludgy solids, very huge, flow rate is very high and dia of the sludgy solids also very high. Na? In such a case, large quantity of solids, and most importantly, when we have a screens, diameter of screen is 20 mm. You want to push solids. In such a case, you need reciprocating pump. I repeat, discharge of sewage is very huge and it is already settled sludgy solid. Third one, you have a screen where diameter of screen is 20 mm. You want to push solids with some force. Then you use reciprocating pump. Centrifugal pump is having a wider area. It's have a very wider area. So when you push solids along with sewage, solids does not clog. Centrifugal pump is there, na? It has a very, very wider area between the vanes of pump. The vanes of pump carry a wider area. So that wider space between the pump vanes. Space between pump vanes is wider. So when you push the flow, solids does not clog, does not stop. So this is the best choice, centrifugal pump. That is the best choice. Then what is pneumatic ejector? Can anybody say what is pneumatic ejector? That is to lift sewage, small quantity of sewage to lift. Septic tank, generally we construct septic tank at far below ground level, and it is a big apartment to send settled sludgy solids from septic tank to push to ground level, to give to road sewer. And there is a colony which is a low-lying area, like this is the main road where sewer pipe is there, but colony is located here. See, these are the houses, colony. Sewer pipe is located here. Now wastewater pipe from each house connected over here. Wastewater from each pipe, each house is connected over here. It should be push up, no? From lower height to higher height to push the wastewater sewage flow. We need pneumatic ejector. To pump sewage from lower head to higher head. Pump sewage from lower head to higher head. From septic tanks of apartment, from sewage flow of low-lying areas, colonies at low-lying areas, to push the sewage to certain heights, pneumatic ejector. Only they are talking here about clogging, not talking about any other thing. So answer is centrifugal pump. You understand? For sludge, for screens, reciprocating pump. Lifting the sewage, pneumatic ejector. Without clogging, just sewage solids, centrifugal pump. Standard EDTA, ethylene diamine tetraesteric acid solution, used to derive which property of water? Turbidity, we say turbidity, platinum cobalt scale. Turbidity, platinum cobalt scale. Silica scale. So turbidity we can give silica scale. Sorry, color we can give platinum cobalt scale. 1 minute. For turbidity we can give silica scale or pharmazine scale. Silica scale or pharmazine scale. DO, dissolved oxygen. We can use starch as an indicator. Sodium thiosulfate. Starch, sodium thiosulfate. Same for residual chlorine also. Either orthotolidine test, OT test, orthotolidine test, or starch iodide test. Same starch and sodium thiosulfate. What is remaining? Hardness. For hardness estimation, we use erythrome black tea as indicator. Erythrome black tea, EBT as indicator. EDTA, ethylene diamine tetraesteric acid as titrant. We call this as a versenate method, complexometric titration, and simply the name itself, EDTA titration experiment. So the easiest question of the entire paper actually, because most of the students know EDTA related to hardness of water. Easiest question of the paper. So this is also easiest. In our notes it is very clearly written. Which population forecasting method suitable to predict future population of young city expanding faster rate? Young and rapidly growing city. Always geometrical rate method. Old and settled city arithmetic rate method. slowly developing city incremental increase method, but young city expanding faster rate geometric rate. Exponential, the name itself, geometric rate method or exponential rate method, the name itself carry that young and rapidly developing city. Minimum width of septic tank. At least the septic tank can carry what width? What width? According to IS 2470 part 1. According to IS 2470 part 1. 750 mm means we can say 75 centimeter is the minimum width. So from the options we can say 70 centimeter. Minimum width, lowest possible width to be taken. IS 2470 part 1, it is 750 mm, 75 centimeter. It is speed of 0.3 meter per second. This is velocity. Velocity. The time required for waste to reach a distance of 30,000 meter length. So it's easy, na? Time traveled is equal to distance by velocity. Time of travel. Time taken to finish the distance travel. Distance traveled by velocity. Distance traveled 30,000 meter per second. Meter per second. Oh, sorry, 30,000 meter distance only. Distance only 1 minute. Distance is 30,000 meter. Time is equal to length by velocity. Distance traveled 30,000 meter. Velocity 0.3 meter per second. It is in meter per second. Please understand, meter per second. We need answer in days. We need answer in terms of days. So we can multiply 24 into 60 into 60. So that this is meter per day. You get your answer in per days. You get your answer in per days. So what are you getting? Please calculate and do it. Okay. Time is given L by V. This is the calculation. Whatever you are getting, please do calculate and give the answer. BOD, the most favorite. Whenever I use it to take the topic of BOD, anywhere, it may be YouTube, it may be Plus Class, it may be throughout my teachings of environmental engineering, whenever I use it to talk about BOD, I will say one word. Without BOD question, there will be no question paper of any competitive exam. 90% of the times it is happening. Obviously happening. Here also. 2.5 ml of raw sewage. 2.5 ml of raw sewage. Diluted to, please understand, 250 ml. 250 ml means they are taking 2.5 ml raw sewage sample A, diluted to 250 ml, making up total volume. Total volume A plus B. What is A plus B? From somewhere they brought 247.5 ml distilled water and added, making total volume as 250 ml. Please understand this. 250 is not a distilled water volume. 250 is a diluted sample of raw water and distilled water. So that a diluted sample volume given. From that we can take dilution factor. Dilution factor A plus B by A, 250 by 2.5, 100. You know na? Dilution factor formula. Dilution factor A plus B by A. Total volume upon sample volume. A plus B is total diluted volume divided by raw sewage volume. 250 by 2.5. 250 by 2.5. Then initial DO 8, final DO 5. Please understand. Initial DO is 8, final DO is 5. Why 5? DOI minus DOF into dilution factor. No need of so many things. No need of dilution kinetics. Nothing required. 5-day BOD, that's it. 8 minus 5 into 100, 300. 300 mg per liter. Some people are shouting. They simply giving BOD, not at all mentioned 5-day BOD. Beta, understand this. Simply BOD means 5-day only. If they want ultimate, they clearly write determine ultimate BOD. Simply BOD means 5-day only, 300 milligram per liter. Which statement is true about oligotrophic lakes? Oligotrophic lakes are purely water containing lakes. Means primary producers are less. Water quality is that much pure. Production of carbon, production of organic matter is very less. So now see, water is poor in nutritive, rich in nutritive, rich in acidic, rich in basic. So oligotrophic lake, what it is doing, it generate carbon at a rate of 50 to 100 milligram per day in 1 meter square area. In 1 meter square area of oligotrophic lake, just very, very small amount, 50 to 100 milligrams of carbon per day per meter square. This much less. In such a case, water is poor regarding what? Nutrients. When you say eutrophic, rich in nutrients, because it generates a huge amount of carbon day to day, but it is poor in nutritive, only 50 to 100 milligram per day per meter square of carbon, poor in nutritive. Match the following we are having. So as an engineering student, having these diseases in environmental engineering and asking, so it's a fun for us to solve. Diarrheal diseases, schistosomiasis, malaria, onchocerciasis. Are Baba, we are not preparing for NEET, but still we have to give answer for such kind of questions. Sometimes kabhi aisa ho jayega. So we have to focus now. So we know diarrhea diseases, amoebic dysentery, or diarrhea caused by microorganisms only. We know this. So A is one. And most of the times we know malaria is caused by mosquito. So option C, option D eliminated. So schistosomiasis, onchocerciasis. Schistosomiasis, when a human being is in contact, unfortunately, with snails in water, especially in oceans, snails are there. When he come in contact with snails, that is going to cause onchocerciasis because of black flies. So B is 2, 3 is, D is 3. 1, 2, 4, 3. Are Babu, I have also done lot of research in internet. I don't know about this. Okay, only I know. microorganism for diarrheal disease, malaria for mosquitoes. So this is a out of the box question. When environmental lapse rate is less than adiabatic lapse rate, ELR less than ALR. Environmental lapse rate less than adiabatic lapse rate. ELR value less than minus 10 degrees Celsius per kilometer. What is it? What is it? Subadiabatic lapse rate. ELR greater than ALR, superadiabatic lapse rate. ELR equal to ALR, neutral lapse rate. ELR less than ALR, subadiabatic lapse rate. Temperature inversion is dt by dz positive. Temperature inversion dt by dz positive. Neutral. ELR equal to ALR. Superadiabatic. ELR greater than ALR. So finally, subadiabatic, ELR less than ALR. Environmental lapse rate less than means temperature decline when altitude go on increasing. Temperature decline less than 10 degrees Celsius, 9.8 degrees Celsius per kilometer. Primary air pollutant. See, 3 questions we are having regarding air pollutant. First, they are asking primary air pollutant from vehicular pollution. Second, they are asking find out secondary air pollutant. Now they are asking what are primary air pollutant. Ozone is secondary. We know this. You eliminate ozone, you get the answer. Sulfur dioxide and oxides of nitrogen. Ozone, 100% obviously secondary air pollutant. You eliminate ozone, you get the answer. Leachate. Leachate is a colored liquid that comes out of when you have dumped the solid waste, in a region, and from the dumping of solid waste in a region in a rainy season, rainwater goes inside, subsurface water goes inside, then it reacts with a lot of colored substances, releasing some colored liquid. That colored leachate is coming from sanitary landfill. Solid waste management. Only one question from solid waste management. For reverse osmosis plant, which of the following statement is true? So for this, first you need to understand how a reverse osmosis plant can operate. So feed water. Feed water means from the source, from the storage reservoir, from a source of storage reservoir, lake where dissolved solids content is more, that water with dissolved solids content given into pump, feed water. That is passing through RO membrane. Reverse osmosis process is going on through the RO membrane. Then higher concentration than feed water. Salts carrying higher concentration than feed water. Rejected, separated out, down. Which are having lower concentration solids called permeate water. Permeate water. Understand? Total dissolved solids of feed water. Total dissolved solids of feed water given to pump. Then pump to RO membrane. It is given to pump to RO membrane. So that RO membrane will separate it into 2 portions. RO membrane will separate it into 2 portions. High concentration salts. High concentration salts rejected into stream. That is rejected into nearby stream. Then removed na salts, low TDS, that is permitted to go to the next treatment or to supply. Permeate water, low concentration. Please write down this. Nowhere it's available. This kind of reverse osmosis question, till now any exam they have not asked. This is the first time they are asking. Feed water TDS, then high concentration reject stream, low concentration to permeate water. Now see the options. TDS of feed stream. So we start with feed stream only. Only one option we are having. Then TDS of reject, TDS of permeate. But they are asking here order based on concentration. Based on concentration, please understand. It's not about order for the flow. It's not about order for the flow. It's about order for which, whether feed water or reject or permeate. Obviously, high concentration solids are rejected. TDS of reject, na? TDS of reject first. High concentration. High concentration is for TDS of reject. High concentration. Then TDS of permeate. What is TDS of permeate? Low concentration. Then in between TDS of feed stream. In between TDS of feed stream. Understand? High concentration salts are reject stream. Low concentration salts are permeate stream. Then remaining feed stream in between, moderate. So option D. For public water supply, number of cobalt scale should not exceed. Cobalt scale we say platinum cobalt scale. Color. Platinum cobalt scale is color. As per IS 10500 2012 standards. Latest standards. Very clear. It's very, very clear. Latest standards. The public water supplies, it must not exceed 15. Okay. Some textbooks it was written 20. That is old. IS 10500 1992 standards. This is 2012 latest we are having 15 ppm. The power requirement to drive centrifugal pump which delivers 10 liter per second discharge. So please understand, discharge 10 liter per second to a head of 10 meter, diameter of pipe 150 mm, overall efficiency of pump 10%, overall efficiency of pump 10%, assuming no losses. What is power requirement? Power is equal to rho QGH, and you need in kilowatts. Density of water 1000, 10 liter per second. How can we write 10 liter per second? We can write this as 0.01 meter cube per second. 0.01 meter cube per second. 10 liter per second, 0.01 meter cube per second. G 9.81. H is 10. H is 10. Divided by, as you need in kilowatts, divided by 1000. Because you need in kilowatts, na, watts to kilowatts conversion. And most important thing, efficiency divided by efficiency, 10% in fraction 0.1. 10% to be taken in fraction 0.1. So do cancel. 1000 getting cancelled. And this 0.1 going up, it will be 100. So 0.1, this was cancelled. You get a 9.81 kilowatts. No need of calci also. Directly we can solve the question. 9.81 kilowatts. Okay. So just you need to remember power is equal to rho QGH and efficiency given rho QGH by efficiency and kilowatts divided by 1000. Okay, done. So guys, I hope we discussed in detail each and every question and it will help you in your upcoming examination SSC JE or State AE or even ESC General Studies GATE Environmental Science and Engineering paper. And the remaining questions same TNPSC AE, Geotechnical, Hydrology, Irrigation, Open Channel Flow, CPM part, all questions we will do fatafat. Don't worry, I will upload the videos soon. So inform your friends, KP Sir and RP Sir are coming to teach under SSC JE State AE category. Exclusive courses by most experienced educator, best content you are going to get. So guys, let's crack it.